Hi everyone, I welcome you all for this session. In this video, I would like to explain in detail about the working procedure for diagonalization of a square matrix. To diagonalize any given square matrix A of order 2 cross 2, we need to follow the following steps. In step 1, find all the eigenvalues, say lambda 1, lambda 2 of a square matrix A. In next step, find the eigenvector, say x1, x2 corresponding to each eigenvalues lambda 1, lambda 2 respectively. In step 3, let us form the model matrix P by using the eigenvector x1, x2. In next step, compute the P inverse by using this appropriate formula that is given by P inverse is equal to adjoint of P divided by determinant of P. Already you are familiar in finding inverse of a matrix. In last step, obtain the diagonal matrix capital D by using this equation. Capital D is equal to P inverse A into P. Here P is model matrix. P inverse is the inverse of model matrix. A is the given matrix. By multiplying these three matrices, we get the required diagonalized matrix for a given square matrix. Now, by considering one simple example, I will try to convey this concept in detail. The first example, diagonalize the matrix A. This is of order 2 cross 2 because our VTU in that syllabus it is restricted only for 2 by 2 matrix. Okay. Now let us move on to the solution part. First construct the characteristic equation of A that is given by determinant of A minus lambda I equals 0. That is the second order determinant. Let us evaluate the second order determinant. We get a quadratic equation in lambda, that is lambda square minus 7 lambda plus 10 equals 0. By solving this quadratic equation, we get the two values for lambda, that is lambda equals 2, lambda equals 5. These two values are called the eigenvalues of a given square matrix A. Now let us construct the matrix equation in the form A minus lambda I into x is equal to 0. Here A minus lambda is the 2 by 2 matrix. Here xy is the unknown matrix of order 2 cross 1. Even the 0 is also a 0 matrix of order 2 cross 1. By multiplying these two and equate to this matrix, we get a system of linear equation in terms of x and y that we call it as equation 1. Now, in the next part, we need to find the eigenvector corresponding to each eigenvalue by using this system of equation 1. Now, in case 1, let us consider the first eigenvalue, lambda equals 2. Now, let us put lambda equals 2 in the system of equation 1. We get x is equal to 2, y is equal to minus 1. Thus, this x1 is the eigenvector corresponding to the eigenvalue lambda equals minus 1. In case 2, let us find the eigenvector corresponding to the eigenvalue lambda equals 5. As usual, let us put lambda equals 5 in the system of equation 1. We get x is equal to 1, y is equal to 1. Here, thus x2 is the eigenvector corresponding to the eigenvalue lambda equals 5. Now let us construct the model matrix P that is given by P equals x1, x2. That means by using the eigenvector x1 and x2, we need to form a model matrix P in this form. Next, let us compute P inverse. By using the standard relation, P inverse equals adjoint of P divided by determinant of P. Already you are familiar in computing adjoint as well as determinant. Let us substitute for adjoint of P and determinant of P. We get the matrix P inverse. Yes, in final step, we need to obtain the diagonalized matrix by using this equation D equals P inverse A into P. Here let us substitute for P inverse, and A is given square matrix, P is the model matrix. By multiplying these three matrices, we get the required diagonalized matrix for the given. This is the required diagonalized matrix for a given square matrix. Okay. Similarly, we can diagonalize any given square matrix by following these 5 steps. Okay. I hope you understand this. Thank you. Thank you all.